Pro wired circuit, so here you can able to see the wind and here you can able to see the solar. Okay, this is the PV and this is the wind above and below. I am connecting the one battery here, okay, to balance the load and source. So first of all go to PV and here I am taking the one solver PV array with radiation and temperature. So after that I already told you we need to go to the boost converter. So this inductor and this IGBT and this diode make a boost converter. So I already told you with the help of MPPT and boost converter we are getting the maximum power. That's why here I am taking the maximum power point control. So in MPPT what we are taking the incremental conductance. That's why I given name here incremental conductance. Okay, so this can take the voltage and current of the PV and give the pulses to our boost converter, and after that it will go to the one storage capacitor, and here we are taking the voltage and current measurements to measure the current and voltage. Okay, so these are the PV values, voltage of the PV, current of the PV, irradiation and temperature. These are the measurement blocks of our solar system. Okay, now go back and below we are connecting the battery here. To see the battery waveforms here I am connecting to one scope. Okay, here you can able to see the state of charge of the battery, whether it is charged or discharging. Okay, so above we need to go for the wind. In this wind system block, here first of all we need to check the wind turbine. So this is the wind turbine. What is the input to the wind turbine? Wind speed rate. So here I'm taking the wind speed and change the input. So after wind turbine we need to give it to the generator to generate the power. So that's why I'm taking this asynchronous machine, nothing but the generator. Generator can generate the power in three-phase form. So here we are getting the three-phase AC here. So to convert the AC to DC I am taking the one project field. So this is the project field. You can convert AC to DC. That's why you can able to see here input blocks are ABC and output blocks are plus and minus. So in between these two you'll get the DC. Okay, so we need to give this DC to one DC to DC converter. So this is the one DC to DC converter because this input value is variable, not constant. To get the constant supply we need to take the one DC to DC converter. So same like solar, here also we are taking the current and voltage measurements to measure the wind current and wind voltage. Okay, so go back. So here it is clear we are getting the two inputs. Two separate sources. So these two separate sources will give into the multi-layer inverter. Okay, these two H-bridge nodes will make a multi-layer inverter. Okay, so these two are connected to the output. This is the R load we are taking. You can take any load. So with the help of LC filter we are taking the load. Why LC filter means if you take the inverter also we are getting the output like this, right, for multi-layer inverter. So this is not pure AC, right? But for load we need a pure AC like this. To convert this into this we need to take the LC passive filter. That's why here in our MATLAB I am taking the simple LC filter to get the purees. So to measure the output voltage and current I am taking the current and voltage measurements both. Okay, and here to give the switching pulses to our inverter I am using the pass width modulation. Sine sol pass width modulation. That's why I am taking the sine wave here and one carrier wave here. And giving to the relation operator to give the pulses to our switches. Just double click on the switch. It will go to our switch. Okay, so like that we can turn on and we can turn off the switches. And below we can able to see the waveforms of our circuit. Run your MATLAB simulation, and click on scopes. Here you can able to see the waveforms. So in the scope 2, you can able to see voltage of the wind and current of the wind. And third one is the product, means power of the wind. So you can able to see the both waveforms. Okay, so first one is the voltage and second one is the current and third one is the power. So you can able to see it will steadily give the output. Okay, so same like that, open the other scope. This is for voltage of the solar and current of the solar and power of the solar. You can able to see the same. So you will give the constant power. Similarly open the other scope. This is for output voltage and output current and output power. So here you can able to see these two graphs will give the DC output. But here in the load we want AC, right? So here we need to get the AC output here. So down click on this scope, then you can able to get the AC output. Okay. So here also in the voltage you will get the AC output. Okay. Now open the below scope. So here you can able to get the voltage, current and the power. That's it. If you want this project contact me, I will give complete assistance and also I will explain in reach and every block clearly through Google Meet.